as Ruth says, I'm Richard Clegg, and I'm the Chief Executive of the Lloyds Register Foundation. And this is all about blockchain today. It's not about the foundation, but I just want to give you a bit of perspective about the foundation so you can understand our motivation in supporting this piece of work in blockchain. Where are we coming from and where do we think we're heading to with this technology? So I've got a number of slides here to give this Google Earth picture of the Lloyds Register Foundation, and I'll end up by landing on this technology of blockchain. So we'll see how it goes anyway. So I just want to start off with 4 or 5 things to know about the foundation. So if you pay attention to this slide, you can go to sleep for the rest of them, okay, because it's got all the information that you need to remember. So first of all, we're really an interesting organisation. We're quite young, but we have a long heritage. It's very strange. We were founded, the Lloyds Register Foundation, 2012, okay? So we're only into our 4th or 5th full year of operation. And we're a charity, and our charitable purpose is to enhance the safety of life and property and advance public education. So we're on the planet for those 2 things, safety and science, technology, engineering related education, those 2 things. We're based in the UK, based in Fenchurch Street, but we operate globally. And I said a moment ago that we're young but have a long heritage. And that long heritage comes from the fact that we are the shareholder of Lloyds Register, which is a 257-year-old organisation. So I quite often describe ourselves as something like a 257-year-old SME. And I'm going to describe this point in a moment on another slide, is that what we've got with Lloyds Register, the group and the foundation is a 21st century model for doing social business. And I'll explain what I mean by that in a moment. So 5 things, remember those about the foundation, you can nod off now, and I'll wake you up when Gary Pogson comes on. This is a depiction of what I've just said about this 21st century model for doing social business. So we're Lloyds Register, and Lloyds Register is made up of 2 parts. There's a trading group and there is a charitable foundation. And we work together, the 2 halves of Lloyds Register, to essentially make the world a safer place. Okay, that's our shared mission. And we're able to do that because of the structure that we've got and the governance that we have in 2 ways. So with our trading arm, trading group, we're able to make the world safer, working with the clients and the sectors that we serve. It's a commercial business, creates a margin. And we're all able to make the world safer on the charity side of LR by working with wider societies and the communities that we serve. So we're able to work with clients, sectors, communities, and societies to make the world a safer place. So that's what I mean about 21st model for social business. Some companies do things to make money, and we make money to do things. Everything goes back into making the world a safer place. I'm just going to sort of chunk down now from this big picture of, you know, what is Lloyds Register about. I just want to explain, we've got this charitable purpose, enhance safety of life and property and advance public education. What do we do, ... in pursuit of that? And this is our strategy there that describes that. So essentially, in pursuit of our charitable purpose, we do the 4 things at the top of this slide here. So we support research, we support skills and education, we support the public understanding of risk, and we are also able to act in a VC-like way to invest in accelerating technology to application for the benefit of society. So those are the 4 things that we get up to in support of our mission. And if you break open the research bit, then you end up with those 4 bullet points at the bottom. Structural integrity, resilience, and human and social factors. Essentially, anything to do with the safety case, the asset, the environment, and the people. That's all that that means. And then emerging technologies. Having been in business for 257 years, if we're going to stop in business, we need to look over the horizon at what's coming next. So that's what we do as well. And that's where blockchain fits for us. So you can see how it fits into our rationale. Okay, just some statistics. It's not all about numbers, it's not about the size of things, but this gives you a feel. And I explained a moment ago that we're quite young, only been around for 4 or 5 years, so everything's ramping up for all of us. If you click the shutter, this is what we look like. At the moment, we've got 78 active grants in 21 countries. We've committed in the past few years just shy of £100 million into the things on the previous slide. And the total value of our active grants at the moment, because many of our grants are for sometimes 10 or even 15 years at a time, long planning horizons to them. And £100 million is the value of that portfolio. Because as the years go by, and year 5 comes in year 6 and year 7, our grants are beginning to stack up on top of each other because they've got long horizons to them. So this portfolio is going to grow. And our planning assumption at the moment is that when we're up to cruising altitude, we'll be about £150 million worth of live grants. And working with organisations like Turing, who can get a leverage and funds that we can't, because we're not a university or anything like that, we can gear our investment by around about a factor of 4, which ... means that 150 million becomes 600 million, over £500 million of research. And so if we just pick the right things to invest in and they do them well, you can do quite a lot of damage with £500 million worth of investment. And the year that we're in, we're forecasting spending around about £32 million this year as the charity part of the foundation. We've done a number of these Foresight Reviews, insight reports. That's just a list of them there. They look something like this on the front cover. This is the one for robotics and autonomous systems. It's not the one for blockchain, but it is relevant. And I didn't cut and paste it out because this blockchain doesn't just stand alone in isolation. We've got a portfolio, a cluster of grants in big data, robotics and autonomous systems, cybersecurity, and blockchain. And all of these, by triangulation, are in this digital and data space, all very important to us. Okay, I've got a couple of slides left, and then I'm going to shut up. This goes right back to 1760, so the formation of Lloyd's Register. And what's that is a picture of is big data, 1760 style. And here is what it looks like. So this is a faithful copy. The original is in the British Museum. But this is the distributed ledger, 1760, of shipping. Okay? And this is what the world looked like when Lloyd's Register started out. So this was, the authoritative, independent, trusted world source of information on shipping in pretty copperplate handwriting. And in order to certify that, we would go around stamping pieces of plate or forgings or whatever with a punch like this, which, if you look at the sharp end of it, has got LR in it. So that's how we certified things, which has given rise to our logo there. And A1 is in there, because A1, we say nowadays A1 is, a symbol, a mark of quality. But if you trace back the origin of where did A1 ever came from, it came from Lloyd's Register. So when we used to classify ships, going back all those centuries, the hull and the substructure would be given a letter, and the masts and the sails would be given a number. So the best you could get from Lloyd's was A1, and subsequently just found its way into common day vocabularies, meaning the best of the best. So that's what it looked like when we started out. But today, it's a bit more complicated like that. And we've got issues with supply chains lengthening, product life cycles shortening, and all of these assets are now interconnected. And you can't produce something like this and write it all down. It's just not possible. And this world that we're in, this very complex, interconnected world, brings with it its own challenges to do with information quality, traceability, security, integrity, and how do you manage, assure that? Okay. And from our perspective, this perspective of the Lloyds Register Foundation, what space is there for innovation in enhancing the safety of life and property? So that's how we've ended up in this space of needing to look at blockchain as part of this other portfolio that I mentioned with robotics and big data. So we're in this spot, and this is why it's so important to us. So I hope that that contextualizes everything and helps a little bit in understanding why we're in the room here today. So thank you very much.
Thank you. Thank you, Richard. So the next part of the agenda we're going to move on to is about a partnership that when we published the big data report and when we looked at what big data means for engineering, and we saw that there's actually a gap. There is a gap in the conversation about big data and what it means for engineered structures, infrastructures, distributed infrastructures. And so we got together with the Alan Turing Institute, which at that time was in its very infancy, and we worked up a program in data, what we're calling data-centric engineering, a program in data-centric engineering. And so the next part of the agenda, I'm going to welcome Mark Girolami, Professor Mark Girolami, who is leading our data-centric engineering and Mark is looking very puzzled over there, who is leading our data-centric engineering program in the Alan Turing Institute. And this report, the big data report, the insight report in distributed ledger technologies, which we're going to hand out to you later, is what we call a daughter document. So it's come from out of the program, and we're going to take forward the recommendations from that report between us and the Alan Turing Institute in partnership. So over to you.
So, my name's Mark, and I'm the director of the Data-Centric Engineering Programme, which is a partnership between the Lloyds Register Foundation and the Alan Turing Institute. Now, just to let you know what the Alan Turing Institute is all about, it is the UK's National Institute for Data Science. Data science is a term that's developed or came out of the discussion about big data. But the government and the biz at the time saw it as really strategic that at a national level, the UK should have a centre of excellence and a centre for thought leadership in data science. And this was the genesis of the Alan Turing Institute. So it was founded in 2015, and really we opened up for business around about September 2016. It's comprised of currently 5 universities, joint venture universities, Cambridge, Oxford, Edinburgh, UCL and Warwick. And the Engineering and Physical Sciences Research Council were given the responsibility to deliver the Alan Turing Institute to the UK. In addition to the universities that form the body of the Institute, we have a number of partners which we consider to be strategic. And the one that's of most interest to this presentation, of course, is the Lloyds Register Foundation, who saw an opportunity right at the very beginning when the Alan Turing Institute was being discussed as something that should be initiated and should be funded across the UK. And as far as the Institute is concerned, from these universities, but also from other universities and other institutions, government bodies and so forth, we're now developing a hub based here in the British Library of researchers who span career levels from PhD students right up to emeritus professors such as our chief exec. And this is very exciting because we have pure mathematicians, applied mathematicians, statisticians, engineers of every flavour, computer scientists of every hue, interacting with each other very much in a self-organising way at present. But these programs, these thematic programs that are aligned to our partners are providing the glue and providing the thematic interest, as it were, to harness all of this intellectual horsepower. So that's the Alan Turing Institute, and if you've got time today, I'm sure you'll be able to walk around and see what we have on the first floor of the British Library. Now, Richard and Ruth mentioned a number of their Foresight Review documents which they'd commissioned, and the one which was the genesis of the data-centric engineering program here at the Alan Turing Institute was the Foresight Review of big data. And that was underlined by the statement towards data-centric engineering. And I think, as Richard mentioned, the whole raison d'etre here is that we want to make engineering, we want to make the services, the processes that engineering facilitates and provides safer. And that's exactly the driving goal of this program. So I was appointed director at the start of this year, and we really have moved quite dramatically in these last 9 months. We have 3 grand challenges which define our program in data-centric engineering. And again, they are all fed from the underlying mission of the foundation, which is to enhance the safety of the person and of property. And if we look at our first grand challenge, we want to ensure that data-centric engineering will enhance the resilience and the robustness of critical infrastructure, the sort of critical infrastructure that we rely upon, whether it's transport networks, energy supply processes, whether it's new services and so forth. So this is one grand challenge, which is the focus of quite a lot of research and research activity, which we'll hear a little bit more about shortly. Now, if we want our critical infrastructure to be resilient, we need to be able to monitor it. And we need to be able to monitor it for what? Well, for catastrophic events, for events with very high consequences. And these typically are very rare events, which sometimes we've never seen before. So how do we monitor these very complex engineering systems? And when I talk about engineering systems, I talk about the interaction, the social interaction between people and communities and engineering processes, engineering systems on that sort of scale. The final one is that if there is information and if there is value in data, and I think that I'm going to steal the slide that Richard put up showing big data 1760 style and big data 2017 style. If data is really going to be valuable, and what we're already seeing in the program is that it is absolutely transformational for the engineering professions across all of the all sectors. Well, if it is the case that data-driven engineering activity is going to be valuable, then we would want to try and look at the design process how we design new power systems, how we design new power plant, how we design new cities or add on to new cities, and how we do this with data. And in essence, what we're trying to do with these three grand challenges is have a system of activity that is interlocked, and the sum of these three parts will be far greater than what we would achieve with any of the three on their own. Now, we've spoken an awful lot about research, but this program is far more than just research. Yes, we want to provide intellectual leadership, and we're doing that, and we're growing that capacity in a very exciting way. But if we just stop there, then we're really failing, and that gearing effect, not just financially, but from a perspective of delivering some impact, we're going to miss out. And so the other focus of the program that we've designed and we're rolling out is also the translation. We want to be able to translate that intellectual leadership that we are providing into industry innovation. So we are engaging very actively with many industries across all engineering sectors. And we really see this as one of the main focuses, foci of the program, is translating innovation into economic benefit for various engineering sectors. Now, if data-centric engineering really is something, and maybe in 10 years we won't be talking about data-centric engineering, but the whole engineering landscape will have completely changed because of this data-centric view of how the engineering sciences are going to progress and how the engineering professions conduct their business, then we're going to have to think about educating a new generation of engineers. We're also going to have to think about educating the current generation of engineers. And so we're looking at a whole strand of activity on education for the engineering professions and developing the engineering sciences curriculum. Finally, again, if data-centric engineering really is a thing of value, and we are going to provide innovation and leadership, and that's going to be translated to high TRLs. Are you getting twitchy? Am I talking far too long? Then we need to have standards for the quality of data, standards for how we process that data and how we certify that that data is telling us what we think it is meant to be telling us. And so these are the four strands of activity that underpin everything that we're doing in this program with the Lloyds Register Foundation at the Turing. I think this is the last slide. This is the overall organisation at the moment. Strategically, we need to have leadership for each of those three grand challenges. And so what we have are three senior academics who all hold professorial chairs who are leading the core activity in each of these challenges. And I'm quite pleased to note that each of them are female. They're not wearing red dresses, but I think this is absolutely superb. And the leadership that they're providing, so Julie McCann, for example, on the first grand challenge of resilient infrastructure, we are working with Thames Water, NEC on looking at resilience and robustness of water distribution supplies, precision agriculture, and the whole emerging science of distributed sensors, a la the Internet of Things. And on we go. In the second grand challenge, we have three main themes looking at transportation. So this is remember, we're trying to monitor complex systems for high consequence events. So the systems that we've looked at are transportation and then cybersecurity, which leads into the whole reason why we're here today, about security and distributed ledger technology. And then some of the theory about how do you predict something that you don't know anything about. and the third one is currently underway. We have a number of early career academics who are group leaders and who are being very actively encouraged by me to build up groups and lead them. And they are all, again, strategically aligned with commercial partners or with government bodies. So I won't talk any more about that. And we have a number of projects that are starting to develop, very excited by them. And yeah, there's a lot of life going on. And I think that's me.
So I want to introduce Gary Pogson, who is the principal author of our distributed ledgers report. Now, when we were looking at how to write this, the really basic question here is putting this technology in the hands of people who aren't specialists. And so we thought that the best way to do that was to give the report writing process to a non-specialist, because if he doesn't understand it, then it won't get in the report. So I'm going to introduce Gary. Gary is not an expert, or was not an expert in distributed ledger technologies, but has become one through this process. So Gary, would you like to explain to us what you've written?
Yep. Good morning. My name is Gary Pogson. My background is research and development and systems engineering. I'm a chartered engineer and a member of the Institution of Mechanical Engineers, so very much not a computer scientist or a coder, if you like. I went into this really with an engineering hat on to look at how this could be used to the benefit of engineered systems. I wonder if it's worth me asking, first of all, now maybe the answer to this is obvious because you're all here, but I wonder how many of you had heard of the phrase distributed ledger technology. There's not many hands. Oh, I suppose there's lots. Okay. I won't go any further then, because if I go and ask the general public, if you like, if they've heard of distributed ledger technology, many of them will say, I can guarantee many of them will absolutely say, no, I've not heard of it. If you ask them if they've heard of blockchain, then you'll probably get more people say, yeah, I've heard of blockchain, but I don't really know what it is. If you ask them about Bitcoin, then there's an awful lot more people that have heard of Bitcoin. And so one of the key barriers to being able to understand whether this technology is going to be of any use to anybody is actually to understand the difference between the different terms. Now, if I was to package, let's say, distributed ledger technology and blockchain into one definition that was sort of easily understandable by everyone, then this is the sort of thing that I would define it as. And this has been my viewpoint on this has been formed from talking to lots and lots of different people. You will get lots of different views, and if you go and say to somebody, if you talk to somebody about blockchain, some people will think that you're talking about a permissionless and open and public system like Bitcoin, whereas some people will have a bit more of a broader concept of what it is, and they might take into account some of the permissioned and enterprise systems that the likes of like Hyperledger, for example. I don't know if anyone's heard of Hyperledger, but it's something that IBM have been involved in developing. So this is really my definition for the collection of technologies, and they're actually underpinned by, if I talk about it in a systems way, they're underpinned by a whole load of components, things like public key encryption technologies, and those components can actually be used to form different system architectures. Bitcoin is one system architecture, or one evolution of these technologies. Ethereum is another. Hyperledger is another. They're all slightly different flavors on the on the same underlying technologies, if you like. So the event's called Hype or Hope, and the reason we called it that was because we recognise that there's a massive amount of hype around this technology. This is just a particular example of one of the quotes that I got off medium.com, but you see these all over the place. places like Twitter. There's all sorts of, it's going to be a panacea for solving all of the world's problems, this technology. You can take this particular one in many ways, but actually I thought it was a bit limited in scope because it only talks about Western civilization. So that's one example of the hype. I've got a few more examples. Of course, a lot of the hype was driven by Bitcoin and the popularity of Bitcoin, which is a cryptocurrency. If you look on this particular website, there's over 800 cryptocurrencies listed on this website. Some of them aren't worth much, but there are 800 listed. And that doesn't include other applications of blockchain and distributed ledger technology that are being demonstrated and put out there. There's a particular capability of some of these blockchains and distributed ledger technologies through the use of smart contracts. And a lot of the hype has been driven over the past year or so by these ICOs, or initial coin offerings. They're like the new version of crowdfunding, really, but using blockchain as a mechanism to do it. As you can see, the numbers are not small. That's just in the first 6 months of this year that approximately that amount of money has been raised through ICOs. And just to give an example of something that makes it look completely silly, somebody invented one of these coins called the useless Ethereum token. And he's developed a really good website about this useless Ethereum token not being worth anything. And he's got a good question and answer session at the bottom of the website that says, for example, can I lose any money on this? And it said, no, of course you can't. This thing's not worth anything in the first place. But he did an ICO for this, and people invested Ether to the tune of about $88,000. It's mind-boggling. And Ethereum has like an app store, a bit like your iOS app store or your Android app store. And there's about 700 applications listed on there at the moment, from things like games, gambling, land management, digital identity. There's all sorts of things on there. Some of these things are obviously going to be potentially useful. Some of them are just going to die. But I guess the key question is all of this hype? Or could there actually be genuine benefits for this technology, for engineered systems, and particularly in enhancing safety? I came to this problem, as I say, as an engineer, and as an engineer I tend to look at things from a requirements or from a needs perspective, particularly if you think about things in a systems engineering way. And so I came up with these 3 questions which really drove the research to write this report. Firstly, what are the engineering challenges that distributed ledger and blockchain technologies can potentially address? And I'll go into some of those in a bit more detail. What are the characteristics of distributed ledger and blockchain technologies? You really, as I mentioned before, they're formed of lots of different components, and there are lots of different types of system out there, and you really need to delve into the detail and the underlying components of those systems to really understand what they're capable of and whether they're going to solve your particular challenge or your problem. Another thing which I'll go into in a bit more detail are the inherent challenges associated with the technologies. They are really quite an infant technology. Bitcoin itself evolved from about 2009, so that hasn't been around a huge amount of time. And it's interesting actually that Bitcoin's been around that amount of time, and still there are a relatively large number of people that haven't heard of it, except through bad publicity. So I'll talk about the challenges as well. The research, I'll just quickly talk about the research, how I went about it. So there's an increasingly enormous amount of academic literature available about these technologies now. There's papers, academic papers, white papers, technology white papers seem to seem to come out every day on new systems and new versions of the technology. And books. There's an increasing amount of books as well, written by some very knowledgeable people in the subject. I also went to a few workshops. There was a workshop I went to which was, it was the start of a programme of work being funded by EPSRC, which was really useful. There was a workshop run by the Association of British Pharmaceutical Industry as well, which was a really useful workshop to go to. And actually just a couple of weeks ago I went to a symposium to do with the legal side of distributed ledger and blockchain, and people were starting to think about that side of thing. But one of the key elements was that we actually held a workshop here in January this year. It's a multidisciplinary workshop. We invited people from academia, from government, from different industries, different businesses within different industries. And as you can see, in all of the work that was done, we've covered quite a wide range of sectors in terms of the types of disciplines that we've involved in the research and the sectors that were involved in the research. So I've picked out 3 key safety challenges from an engineering perspective here. These are developed in more detail within the report. But one of the key things, the first thing really, the top thing on my list, particularly in light of the data-centric engineering programme, is this increase in reliance on data and engineering. And in order for that data to be relied on in an engineered system, that you need to have assurance of that data. You need to make sure that that data has come from the source that you're expecting it to come from, and it hasn't been tampered with in any way. You could imagine how tampering with some sort of engine control system on an aircraft might have pretty disastrous consequences from a safety perspective. Another thing, which is actually where, which is really where I came into this subject area, is to do with supply chains. In Lloyd's Register, I've worked on developing our quality assurance schemes, and I've had first-hand experience of supply chains and how complex these are. And you'll see, if you look at supply chains, and you look at some of the work, for example, by Europol, there's some quite a lot of concern about how opaque some of these supply chains are. And there's a belief that if you make what's going on in that supply chain more transparent, then it will encourage those who are not playing by the rules to either play by the rules or to get out of the business. And qualified and experienced personnel. They're an integrated part of many systems. In fact, I would argue all systems, depending upon the level at which you involve them. You know, if you're talking about a computer system, somebody has programmed that computer system. Somebody's produced the hardware for that system. And so having the right personnel involved in the design or the operation or even the disposal of that system is essential to the safety of the components in that system or the equipment in that system. So there's quite a few opportunities I see in light of what I've learned about the technology. Supply chain traceability and provenance, and I'll talk about an example of how it's being used. Food is the example I've picked up on, but you can see that that's then scalable to things like engineering supplies, and having traceability of a product all the way from the point where the original materials are made through to reusing that product or recycling that product, and making sure that some of the harmful materials are not being willy-nilly disposed of or being passed off to areas of the world that don't have knowledge about some of the safety implications of those materials. And medical supplies as well. There are reports that there is counterfeiting in the supply chain of pharmaceuticals, for example. And so it has the potential to provide transparency over the genuine products in the pharmaceutical industry as well. Secure sharing and logging of data. I debated over to whether to put this one in here, but I think that there are applications for this. The reason I debated it is because there are already mature technologies that can be used to track data within IoT systems, for example. But I think DLT and blockchain do have a role to play, particularly as those IoT networks become a lot more distributed, and you've got a lot more people writing to the system, and some of those actors who are writing to the system, potentially there's an issue with trust associated with those actors writing to the system. And there's actually, I've seen lots of work going on with regards to smart energy supplies. And digital identity and qualifications of people. There's a couple of areas I've picked out here. One is in terms of maintenance. I've heard a couple of, 2 or 3 actually, examples of people talking about the potential for distributed ledger or blockchain technology to immutably record people's qualifications and experience in terms of, for example, carrying out maintenance on aircraft. It's already a fairly well regulated industry, but what this would do is not only it could provide a secure digital record of who has carried out work on an asset, but it could also provide a secure record of the sorts of parts that have been used in carrying out the maintenance of that asset as well. I've also seen digital identity, examples of digital identity coming up, for example, in distributing international aid and being able to provide people with an identity that they haven't had previously to enable them access to international aid. So here's 3 examples of where the technology is being used in the real world. We have somebody on the panel today from Marine Transport International. They've developed a system for verification of container mass. SOLAS, which is the Safety of Life at Sea international regulations, has a relatively recent requirement for verifying the mass of a container before it goes on board a ship. And this system has been developed in order to provide that capability and try and reduce some of the complexity and time wasted when, like at the port, for example, before the container has been loaded onto the ship. Okay, I better speed through. Food supply chain provenance. I've had conversations with Provenance about this, and they've got some really good examples of how they've used the technology on their website. A particular example was for tracking tuna in the supply chain, making sure, for example, that a particular type of tuna is actually that particular type of tuna all the way through the supply chain. And there's a fairly well publicised example of AP Møller-Mærsk working with IBM to develop a system for tracking containers. And I think they mentioned that they were talking about having 10 million containers tracked on the system within a year or so. I'll have to skip through these very quickly. There's lots more detail about these within the report, but interfaces and operability. One of the key issues with this, if you're talking about physical goods, interfaces and operability are a key issue. If you've got this really secure digital system with a mathematical improbability of being able to subvert the system, but you've got a really easy way of counterfeiting the actual product or the thing that links that physical product with the digital representation, then there's almost no point in having the really secure digital system. But that's really a systems issue. It's not really a specific issue of distributed ledgers and blockchain. It's more an issue to do with digitalization and physical products. Scalability is an issue that's being looked at quite widely, especially for blockchain systems like Ethereum and Bitcoin. If you're really talking about big data and processing big data in an engineering system on a live basis, as we're likely to do as we move forward, then some of these systems, as they stand at the moment, are just not suited to processing those large amounts of data. But there are organisations that are developing systems using some of those underlying components of the technology to provide the immutability and the secure logging capability, but also have the large throughputs of data. Privacy and transparency, you have to consider whether, the level to which you want transparency of what's going on the blockchain versus how private you need the information to be. So there's some issues around having selective privacy on blockchain. Bitcoin itself has like a pseudo-anonymous capability. It's mentioned that it's anonymous, but there have been reports that you can actually track the movements of money by looking at what goes on between different addresses on the blockchain. Governance. If you know about Bitcoin, you'll know that there's been a few things going on in Bitcoin recently, and Bitcoin has actually split into two different coins. And Bitcoin, it's described and it's enthused by the people that are really into Bitcoin, that it's this disintermediated distributed system. But in reality, it's controlled by a very small number of players. It's controlled by the core developers, and it's controlled by, I'm not going to go into mining, but it's controlled by the large mining pools on the system. But also there are legal issues. I mentioned that there are people starting to look at the legal issues with these. And the law really needs to take account of these sorts of technologies, but the technology also needs to take account of the law as well. Off-chain assets like cars or physical assets have existing laws that control ownership or access to those particular assets that the technology can't take account of as it currently stands. Standardization, Mark mentioned standardization. Engineering is a thing that really, standardization is an integral part of engineering, and the engineering community will expect some level of standardization around these technologies, partly to provide some of the interoperability with existing systems. Quantum computing, this was another one where I debated whether or not to put it on here. And it's not really, at the moment, it's not really an issue with distributed ledgers and blockchain. But some of the people I've spoken to say we really need to at least consider a post-quantum world in the context of distributed ledger technologies and blockchain, because it's been reported that it has the potential to break public key encryption, for example. So there's two key findings I see from the work that I've conducted. One is it's just plain distributed ledger technology and blockchain really does offer benefits for enhancing the safety of engineered systems, but there's a caveat to that. It's a finding and a caveat, and that is any solution, and I guess this is general systems engineering practice, any solution needs to consider the specific challenge being addressed. And my view is that distributed ledger and blockchain technologies, they're not really there to provide incremental changes that you would otherwise have been able to do just by some digitalization process that you're going through. They're really something that should be used to cause a paradigm shift in whatever it is that you're doing. So three key recommendations out of the report. One is develop leadership and support consortia within sectors. We've spoken to many people, and bootstrapping one of these systems is really difficult unless you've got all the stakeholders on board. So you really need to make sure you interact and get the support from the different stakeholders in bootstrapping one of these systems. Grow capability and understanding. As I mentioned, I've got like this general definition for what blockchain and distributed ledger technology is, but you really need to dive into in a bit more detail. Well, actually, what is distributed ledger technology? What is blockchain? What is a hashing algorithm? You need to dive into some of these particular components and some of these terms in order to really understand whether it's going to be useful for your particular application. And the engineering community really needs to have a better understanding of the technology if it's going to use this to solve some of its safety challenges. And three is really linked to that. I think what the engineering community could do with is actually a mapping of technology options against some of the sector needs, because whilst there are some general needs that span across all of the sectors, some of the sectors themselves have some very specific challenges in terms of safety. And I think we really need to go out and we need to discuss with the individual sectors and dive into some of the specific challenges of those sectors to work out whether these technologies can really help them. And I'm going to hand over to Ruth to go on to the next steps.
Super. Thanks very much. Thanks very much, Gary. So that was the end. That's where the report finishes, and where we pick up as the Alan Turing Institute and the Lloyds Register Foundation, where we pick up on those recommendations. So as a set of next steps against those 3 recommendations, we think a first good step is to address this consideration of an end-to-end system and getting all those the actors together to look at how a blockchain can work in that end-to-end system. So we're looking to support a consortium of that sort, and we think that the maritime sector offers the sort of easiest thing for us to start with, and where our group, who has a maritime heritage, can bring together some of those consortium members to make most sense for us. So that's the first step. The second and third steps, number 2 is the skills and training needs. And you remember that Mark Girolami said that within the program here at Turing, we have a skills stream. And so we're going to take that, what do we need to know, and how can we build that understanding? We're going to take that back into the program and look at how we can build up from that recommendation. And the third step, which was about actually understanding what the technology needs are for the sectors. Is the blockchain, is a distributed ledger the most appropriate solution to actually solving the problem? And actually within the Turing Institute, there are lots of other alternatives. There's lots of new algorithm development. There's new technologies coming online. So to help customers understand what kind of technology is most appropriate and whether a blockchain is the most appropriate type technology. So that will also be something which the program will take up and provide some leadership in the future.
Hi, I'm Alpesh Doshi from Pinterest, as it says there. I'm a technologist by background, did a degree in computer science, so I understand the technology, but also now really run a business which focuses on helping companies understand not just blockchain, but there's massive changes going on in almost every industry. So Gary's just asked me to talk a couple of minutes about what we're seeing and what we're doing. So my history on blockchain actively goes back to 3 years ago, literally 3 years ago in October time, where I met the Ethereum guys who shared our office. And like, being curious as I am, I said, what is this? What's this stuff? And it was Ethereum. I thought, wow. When I looked at it and spent 3 months trying to learn about it, and not do anything, just read and understand. It took me 3 months just to understand it. I thought, this is going to change the world. It's going to change everything. Winding forward to 3 years later, what we've seen is really the maturity of the application of this technology across different industries is still very, very early. In terms of live application of these things, it's still very early. The early adopters were in financial services. But again, if you look in financial services, where are the live applications of this? There aren't any yet. There's complexity in there. What we've seen this year is other industries and travel, pharmaceuticals, oil and gas, and a bunch of others at different stages of maturity. Now, this is obviously driven by business need. It's not driven by technology. It's driven by business need. What business problems does this solve, and what could we do with this, and how does it transform business? So if we take the oil and gas market, for example, there's multiple business drivers and dangers in the market that oil companies are looking at. Sustainability, clean energy. Oil companies are going, wow, where are we going to be? What are we going to be as a business? And this applies to all the different industries. The good thing is it's not driven by technology, although a lot of the early POCs are driven by technology, which I don't think is the right way to do it. Experimentation's great, but you need to shift it from a technical conversation to, okay, well, what is this going to do for our business? And over the last 18 months, what we've been thinking about is, okay, how is this going to get adopted to scale? How are you going to get adoption and scale to implement this kind of technology? Now, one of the fundamental things around blockchain is it's decentralized. It's not controlled in a single database or in a hub. It's decentralized. So you need a network of companies and parties involved in to collaborate and work together. So to be able to do that, back in January when I presented about building consortia. And there are lots of consortia around, but they're very focused on technology. So Corda, if you've heard of R3 Corda, which is the financial services one, and lots of others, mainly focused on Hyperledger, which Gary mentioned, focused on technology. If we want this kind of technology to get adopted, then you have to think about an open source software model alongside a driven by an open source, if you like, consortia model, not driven by companies who have vested interests in doing things in a particular way. And a lot of the current consortia, R3 being the biggest, they're driven by the largest banks in the world who are forcing the direction of the software. You need an independent set of parties that says, hey, we're going to focus on solving the problems and not be influenced by big players who may have invested millions into the consortia. Not that that's the kind of model I think will work. So to make this work in the next 1, 2, 3 years, I think, as part of the recommendation talking about marine consortia, we've spent a long time understanding the governance compliance models around how you build a software that will run that consortia, because that's what's going to be needed. And we're working in multiple different sectors. One of the ones that Gary suggested that I talk about is the pharmaceutical sector. In the pharma sector, there are some business drivers, which is one of the directives called the Falsified Medicines Directive around provenance in medicine. So that is driving a lot of change. But what we're seeing is companies and software companies like IBM is an example where they're trying to own the IP that's built. And no organization, any supply chain is ever going to let a single company own that software and be beholden to that software company. It's not going to happen. So you have to build an open source consortia. And that's what a few of the people we're dealing with in the pharmaceutical sector realize. And so we're working with a couple of the big accounting firms and some of the big pharmas to try and figure out what should a consortia look like. So it's exciting times anyway. So in the Q&A, or come and find me, or find me on the internet. My name's out there. I'm happy to talk about this much more.
Thanks, Alpesh. It's quite remarkable that a year later, when we presented here at the Turing Institute, I've now got a lot of similar thoughts in terms of what you just spoke about now. So marine transport started off as an old world service provider. We're fast becoming a technology provider. I'm no means a technologist, so if I can do it, anybody can do it. But we're racing towards becoming a blockchain as a service provider. We've got applications running on a blockchain, and we're creating value. And we were one of the companies featured in the earlier slide from Gary. And I think you can find us on page number 34. But I won't go too much in depth of what the kind of opportunities are in this technology. It's immense. We released our white paper, which was attested to by the University of Copenhagen. We had about 320 requests, and our initial focus was on container shipping and the use of blockchain as an infrastructure. And it became very apparent very quickly that our little segment of the ocean was not the segment that we should be focusing on. Bulk shipping, ports, aviation, MRO, maintenance and repair orders, it's very wide-reaching. And this has given us a lot of excitement in terms of where MTI can go as a business. But if you want to look at the converse opinions, obviously I'm converted. I'm an investor in cryptocurrencies. My business is very based on blockchain, and I think the one issue or stumbling block that MTI had was getting those actors to connect on a ledger and finding the business rationale for us to create that sharing. The technology is very misunderstood. People think they're giving away their data on a network, which inherently they aren't. So there's still an inherent lack of education that goes around the technology. And I think if you look at it from a business perspective, the IT department will probably understand it. The operational department will probably say, oh, it's going to affect my job. But the people that probably need to really understand it the most, which are the commercial bunch, simply don't really care about blockchain technology. And I think if you go into any room or any seminar or any company selling blockchain, you're probably not selling the right technology. You've got to sell the solution. So it's been a whirlwind experience. It's been a great experience in terms of creating this as a first timer in the technology sphere. And we had a whole bunch of press. We're very referenceable, and thankfully we had one of the JOC journalists in America refer to what we're doing as creating the holy grail of shipping by creating that interoperability between various different data silos. And from my experience, I think the industry has probably the most to gain, or rather than the industry, or business in general has the most to gain by unlocking these data silos, creating that interoperability, the automation of that data, and creating value. And one of the biggest benefits towards industry that we found is cost saving. Automate the data, save money. Everybody will talk to you about that, but like I mentioned earlier, you've got those various different challenges that you need to overcome. And the main one is, what is the business case or incentivization for businesses to interact over blockchain? But yep, thank you very much.
Thank you. Okay, so this is an opportunity now for you to either ask questions or to share your own insights. So I think we've got a range of people in the room, some who have expertise in distributed ledger technologies and some who just would like to know what it means for them. So I'm going to open the floor. If anyone wants to start us off? Yeah. Thanks.
Hi, I had a couple of questions, if that's okay. The first is, if you want, I'll introduce myself. My name's Navin. I'm a doctor over at UCLH, but I've set up a research lab for healthcare in UCL Centre for Blockchain Technologies as well. If we wanted to link up with the Turing Institute with some of this, how would we go about that? That's number one. And number two, the reason I got into this was not about value transfer, it was about data integrity and provenance. And everything I looked at beforehand, you're talking about 7 transactions a second in the whole world, which doesn't seem, you're talking about scalability. So you're saying there's an issue with scalability. That's a massive issue. And because everything happens in serial rather than parallel, I don't think a traditional blockchain will work. And that's why I ended up joining. Controversial, but the IOTA Foundation, which is a different DLT, so I'm a member of that foundation, and that's what I'm looking at. So is anyone else looking at that kind of stuff? And what do you think about permissioned versus permissionless? Because that's the only way to do it. Yeah. That's a heck of a lot of questions.
Well, the first question we'll deal with over lunch, and Darren will help you how to get into the Alan Turing Institute, but the other questions over to the panel.
So at MTR, we went through all the various different technologies: Bitcoin, blockchain, Ethereum, scalability, how many transactions per second. And we've actually bumped into a very good or interesting company that are just based here in Liverpool Street called Agility Sciences, ex-Adeptra, level 42, C4DR. The problems that you're talking about, they've solved them. Very, very interesting company. Basically, the network can transact as fast as you throw. Compute power at it. It's very cost effective, extremely scalable, because as far as we're concerned, if an industry like shipping is going to adopt it, it's got to be very cheap and accessible to everybody. So providing a cloud storage device such as Amazon Web Services or whatever you want can actually power the network. And effectively we do something called activity streaming, which we can run multiple different chains at the same time from different data sources. And we threw in a protocol of territoriality, which I don't think anybody's looked at, and that creates a provenance of data from a specific device. And we've spoken to Sandeep from the National Physical Laboratory about it too, but we can pinpoint data to a specific mechanism and follow that through our system. And the basic principle that we use when we worked on our proof of concept was reverse engineering the problem and creating the data provenance that follows the various different sources coming into the network.
That sounds very much like a private ledger.
No, it's hybrid.
Okay, Alpesh, do you want to?
I have to say the scalability thing is a red herring. Number one, if you look at how the web developed, scalability has always been an issue from the beginning of the web. What happened over time is people developed the technology to be able to scale the web, and now we can scale it. And there's still issues around scaling the web, so streaming content is a big problem, right, still. But it's doable, it's doable. By the time the need to scale to millions of transactions a second, or whatever, hundreds of thousands of millions of transactions a second happen, there's a whole bunch of engineering talent out there, all looking at IOTA's one, IOTA Foundation's one. Now, challenge with these kinds of implementations is they're all proprietary. No organization of any commercial organization is ever going to rely on one piece of technology to run their supply chain. It's not going to happen. Doesn't matter. You got to get everybody in the supply chain to agree to use that technology. Never ever going to happen. So it's scalability on its own is not, for me, it's going to get solved. I don't worry about it. It'll get solved. Secondly, anybody who says they have proprietary technology that can scale, nobody will use it because every company, they're not going to let a company own it. If Tim Berners-Lee, when he created the web, said, I'm going to license HTTP and I'm going to get a pip every time somebody uses it, we wouldn't have the web today. Right? And so that's my challenge with these kinds of models, that the models have to be open source, they have to be shared, they have to be collaborative. And we've got some key foundations. IOTA, you can argue, big argument. The jury's out for that, but Ethereum and Hyperledger are there. Ethereum Foundation is there. It's open source, and those kinds of things are the ones that are going to work longer term because they're all open and not controlled by a large organization like Hyperledger is, because the motivation of the vendors in the Hyperledger have specific commercial motivations. Okay. When the web started, that didn't happen. And you can see what's happened with the web. And I think the same thing's going to happen with blockchain.
Super, thank you. And I think the question's out there, and we can pick that up over lunch as well. Is there another question? Yes.
Thank you. How long do you think this will last until quantum computing just means that your security doesn't actually work anymore? Will you have basically fixed the scalability issues before quantum computers mean that they don't matter anymore?
But in what context?
In terms of just cracking the encryption on it.
Encrypted with quantum computing.
Well, again, I'm not worried about it. If you want to make it more complicated, you just change cryptography. If you look at SHA, everything that runs on HTTPS right now has been cracked, but you need large amounts of computing power. I don't know whether this kind of quantum computing is going to make that much difference to breaking cryptography codes.
The answer we have is encrypted with quantum computing.
There's a statement by the US government that says that the public key encryption is potentially sensitive or could be cracked by quantum computing. However, there's also some work which is published by Ericsson, which I referenced in the report, who say that actually some things like the hashing algorithms, they reckon are actually secure to things like quantum computing. I guess part of the answer is it depends on how long it's going to take to get quantum computing to be useful for everybody. And then we'll have to see how quickly they can crack one of these things.
Okay. Is there a final question or point to make? Laura, would you like to?
This is a question relating to the consortium. Did you look at the 5G and the architecture in terms of governance and how it's structured?
5G meaning the telecom center?
Yes.
No, I haven't, no. No.
Because the way the 5G is structured, I think there are parallel elements that you can drag information, because once the 5G will come, it will restructure the way business actually is shaped in terms of using the same bands. So it's something that links towards the blockchain, which can feed back.
I'll have a look. I think, but actually, good point there that I didn't mention around the consortium model. Because of the way the consortium model works, the way commercial companies, whether it's people using distributed ledger in the supply chain or software companies building applications that use that, that's all also going to change. The business model and how money is made is going to change. I didn't mention that, but that's a fundamental piece. Any vendors, any organizations going towards saying, well, I'm going to control this. Not going to happen. I don't believe it'll happen. But I'll have a look at the 5G stuff.
With 5G, it would be totally linear.
Cool.
Okay, I'm going to draw that discussion to a close, but we have half hour for lunch now, and I hope that you can continue the discussion. You've seen the people who are experts in this area. Before we close, I just want to thank a few people. Thank you to the Turing Institute for arranging and hosting us, and thank you to Kathy and the comms team here at Lloyds Register Foundation as well for what they've done to get this report out. If the report is delivered during lunchtime, you can take away a hard copy, but it's certainly electronically available. But finally, I'd like you to just join me in thanking Gary Pogson for the work that he's done in putting this together and stepping outside of his comfort zone to publish on a very complex topic. Thank you.